The Faust edition is a hybrid critical edition of Johann Wolfgang Goethe's tragedy Faust. It features all 556 currently known manuscripts, together with the relevant prints in a variety of interlinked visualizations that intend to provide insight into the genesis of the text. For example, a synoptic apparatus shows all variants of a verse in chronological order and allows to navigate to the respective point in each participating witness. A genetic bar graph shows an overview of the development of any range of verses, but how to determine the chronological order and the approximate dating of witnesses and variants, the manuscripts typically don't have a date written onto them. More than 100 years of research and editorial activity provides a lot of insight, but the typical study refers only to a few manuscripts and mostly sets them in relation instead of providing absolute dates. Renate Fischer-Lamberg's stemmata of 2 acts of Faust Part 2 mark the practical limit of how much of this information can be aggregated manually, so we tried an algorithmic approach. To do this, the statements from the literature have been extracted and modeled either as absolute datings, that state that a certain manuscript has been written not earlier or not later than a certain date, or as relative datings, indicating a witness has been written before, after, or about the same time as another witness. These statements are combined into a graph, with witnesses and absolute dates as nodes and before relations as edges. Theoretically, this is a DAG, a directed acyclic graph, and the statements can now be flattened into a consistent topological ordering, and absolute dating limits can be tightened by looking at the closest indirect assertions near to each witness. Unfortunately, some of the assertions contradict each other. In the graph, contradictions appear as cycles. Here, one of the cycles marked in purple, which prevent both kinds of these deductions. It is possible to remove edges until there are no more contradictions. In our graphs, we usually mark these in red with dashed lines. There's even an algorithm that removes only the minimal set of edges to make the graph cycle-free. However, there's no guarantee that those minimal conflict edges represent those assertions that are actually wrong. They're heuristics, like a weighting scheme, but ultimately we present the conflicting assertions to the scholars using a user interface, who can then influence the graph with their decisions. To complicate things further, a single document may contain multiple inscriptions. For example, this single sheet has verses belonging to different parts of Faust on the front and on the back, and it has long been assumed that they have been written 25 years apart. Since there may be assertions on both single inscriptions, as well as on the whole witness thereon, conflicts might be the consequence of this aspect of the modeling. We have experimented with some variants of this model. To deal with the inscriptions case, one possibility is to copy assertions about the inscriptions to their corresponding witnesses. For example, we have no absolute dating about the witness 21H19, shown in this subgraph to the left. If we copy the assertions about its two inscriptions to the witness, as shown here with the arrows with the empty head, we gain both upper and lower limits for the witness. However, this assertion copying might be a little bold, for example, when we have no information about only one of multiple inscriptions. This assertion copying has changed the ordering of 17 references in the whole graph, and it has helped adding or modifying date limits in a similar range. It has also introduced 4 new conflicts, however. There are some assertions that indicate that two witnesses have been written at about the same time without stating an explicit order. Integrating them is not straightforward, since our graph edges have a happens after semantics. We've modeled this by introducing artificial before and after nodes. For example, here we have the two witnesses, HP 190 and P 198 A, which are about synchronous. And we're adding two artificial nodes before and after this these nodes that are linked to the witnesses with special synchronicity edges. While this doesn't supply new absolute dates, it helps with the overall topological order. For example, if we don't have these synchronicity links, HP 119 would be sorted to the beginning of the whole graph, of the whole witness order, because we have practically no information about it. When we do add the links, this sorts HP 190 immediately before the other witness, HP 190A, for which we have some dating. If we would like to copy dating information across the synchronicity edges, we can do so by copying assertions about any of the nodes to the artificial before and after anchors, like shown in this graph. This again by small witness information using bold inference. We are also experimenting with representing witnesses and inscriptions as intervals, modeled using two nodes marking the start and the end of the working phase. While variations on this approach allow for modeling various forms of overlap, we still need to evaluate the impact on our data. Ultimately, our modeling approach does not provide the definitive witness order, but it does offer an intermediate step consistent with most of the available Faust research, and by various interactive visualizations, a tool to assess current and spark future research. If you're interested, visit faustedition.net to access all contents of the edition. All transcriptions, data, and software are also available on GitHub in source form.